Hello, and welcome to 5 Minute Math. Today we are looking at the geometric concept of determining perpendicular lines, specifically how we can find a line given a point that's perpendicular to another line, and we'll do it in 5 minutes or less. So the first thing we need to know is that the slopes of perpendicular lines are negative reciprocals. So we need to find the slope of the given line, and then we're going to find the negative reciprocal. That will be the slope of the perpendicular line. So let's find the slope of our first line, right? Remember that's going to be our change in y over our change in x. So we've got our y's is 10 minus, and then I've got a negative 11, and then I've got a 0 minus 7. So this ends up being a positive, right? That's going to be a 21 over negative 7. So my original slope is negative 3, and that tracks because it's very steep, right? The larger the integer, the larger the number, the steeper it is, and it's a negative, so it moves down from left to right. I need to find the negative reciprocal. So if my slope is negative 3, I'm going to rewrite this as negative 3 over 1, because the reciprocal means I'm going to flip it upside down. So my new slope, so I'm going to make this my first slope, my new slope is going to be flipped upside down. So instead of 3 over 1, it's going to be 1 over 3. That was a negative, so this is going to be the negative of negative, which makes it positive. So I need a slope of 1/3 that goes through this line. Well, I can use my point slope form. So this is going to be my y minus y1 equals my m, and then x minus x1. So now that I know my slope, that's the biggest thing I needed to find. It's a negative reciprocal to the original line, so my slope is going to be 1/3. I've got my y and my x of my point P, so my y is going to be, let's see, 5. And my y is 5, and my slope is 1/3, and my x is 7. So now all I need to do is distribute this out, solve for y, and I'll have my new equation. So this is going to be y minus 5 equals 1/3 x minus, and then 7/3. And then what I need to do is I need to add that 5 to both sides, right? I'm going to add 5. And really 5, I can reimagine that as 15/3. And so 15/3 minus 7/3 is going to be 8/3. So I'm going to have 1/3 x plus 8/3. That's my equation. If I wanted to, I could graph it. So you see I've graphed a line, and we have a slope of 1/3. And you notice that it's got that y-intercept right there at 8/3, which is really 2 and 2/3. So let's look at another example. So now we have to write an equation for a line, and they're going to give us a point. It's going to pass through this point right here, and it's going to be perpendicular to this particular line, and they give it to us in slope-intercept form. The only thing I really need to know from this line is the fact that it has a slope of 1/4, and that my new equation has to have a line that is perpendicular to it. So remember, our perpendicular line needs to have a negative reciprocal slope. So if my original slope is 1/4, then my new slope is going to need to be first the reciprocal. So it's going to be 4 over 1, which really we can just call 4, and it needs to be a negative. So it needs to have a negative 4 as a slope, and that would give me a perpendicular line. I'm not super interested in the negative 7 as the y-intercept, because I'm going to use point slope form. So y minus y1 equals m, and then x minus x1. What I needed from that original line was the slope, so I can grab it and flip it and make it negative to get the new slope. So now I just need my negative 8, so y minus negative 8. I've got my negative 4 as my slope, and then x minus, and then I've got a negative 1. And I've got a y plus 8 equals negative 4, and then x plus 1. Let's distribute that out. Negative 4x minus 4. Let's subtract 8 from both sides. So we're going to get an equation, which we could graph if we wanted to, of y equals negative 4x minus 12.